Hi, this is my lab for Physics 2, and we analyzed the magnetic field of a bar magnet. So in this lab, we wanted to measure the magnetic field of a bar magnet based on the observation location from the magnet. We wanted to predict an on-axis magnetic field and the off-axis, and we found that it was negative 2.837 newtons, and the magnetic dipole moment was 4.582 1 over amperes. And the system was the bar magnet, and the surroundings were the earth and anything else that produces a magnetic field. So we used these for our calculations: the Biot-Savart law, the magnetic field of a dipole, and the distance dependence formula. And so this was our process taken from the procedure, where we used an app on our phones to orient our phones to ensure that Earth's magnetic field and the magnometer are orthogonal to each other. And then we found where the magnometer is located by moving the phone on the parallel and perpendicular axis. So we found an equal distance. Then we calculated data for all these different lengths. These were all lengths in centimeters. And so all of our calculations had to be in meters. And yeah. And we got this graph from finding the magnetic field of the bar at different locations. And that's how we derived this equation. And then for our calculations, these are the values that we used that we had found earlier. And then we got the off-axis data as well. Then we computationally derived what the magnetic field would be through these glow script calculations. And then this is what we got out. You can see that the orange are on the parallel axis and the teal is the perpendicular, so they face in opposite directions. And the parallel is also 2 times stronger than the perpendicular, which models the calculation of a dipole moment. And so we did assume that the bar magnet acts as a magnetic dipole, and some of them were not working completely accurately. And we know that magnetic fields decrease as the distance increases, but the errors could be other magnetic objects like laptops and phones such near the magnet. And then also the precision of the magnetometer is not the perfect, and the location on the iPhone could definitely have been inaccurate. And so some observations we had throughout this lab was that the magnetometer, being far away from the magnet, measures a near zero magnetic field in the x direction. And we also learned that the magnetometer moves closer to the magnet. The measured x component of the magnetic field increases. So that leads us to our what if question. And the first one is, what if we hadn't oriented our experiment to compensate for magnetic north and instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would the results have changed? And so the magnetic field of the Earth would interfere with the magnetic field of the bar magnet, and it would lead us to more inaccurate results. And then if we were to stick 2 identical bar magnets together end to end, how would it differ, and how would we expect our measurements to differ? So since we're connecting the bar magnets to where they're essentially like added up in series, then we would be able to like add up their dipole, and it would increase their magnetic field. However, the direction would stay the same, so it would be mainly just a difference in magnitude and a difference in direction. Once again, I think in this experiment it's important to note that we had definitely a lot of room for error, but it was very opening to see that relationship by measuring it ourselves. And yeah, thank you so much.